Hi student, in this video lecture we are going to study the hidden surface algorithm. In that we is considering the first one, backspace removal algorithm. So when we considering black face removal algorithm, it can be used to plot only surfaces which will face the camera. That means we considering the surfaces which will face the camera. So face the camera. So the object of the back side are not visible. This method will remove the 50% polygon from the scenes if the parallel projection is used. If the perspective projection is used, then we use more than 50%, more than 40% of visible will be removed when we use the perspective projection, right? So the object is nearer to the center of projection, number of polygons from the back will be removed. So when we considering the projection is taken, any projector ray from the center of projection through viewing the screen to the object pieces object at 2 points. One is visible from the surface and another is the not visible, that is the back surfaces. So when we considering this algorithm, right, this algorithm acts as the pre-processing steps for another algorithm, right? It can be represented by the geometry. It can be represented by the geometrically. Each polygon has the several vertex. Each polygon having the several vertex, and all vertices are numbered. First one, vertices are numbered in clockwise. Then the normal m1 is generated across product of any two successive edges vectors, and this m1 is represent vector perpendicular to face and point outward from polyhedral surface, right? And when we considering this m1 is the normal, right? And this normal is generated a cross product of any two successive edge vector. This m1 represents the vector perpendicular to the face point outward from the polyhedron surfaces, that is n1 is equal to v2 minus v1 into v3 minus v2. If and 1 into p is greater than or equal to 0, then visible, that is the surface is visible, all else, or n1 into p is less than 0, then invisible, right? This is the algorithm, right? This is the main idea about the backspace removal. So when we're considering the backspace removal, we just each polygon has the we considering the polygon, right? Each polygon having the several vertices. All vertices are the numbered in clockwise. Then normal m1 is generated the cross product of the any two successive edges vector. Then this m1 is also represent the vector perpendicular to the faces and point outward from the polygon surface, and it works in mathematical expression, right? N1 is equal to v2 minus v1 into bracket v3 minus v2. If n1 dot p is greater than or equal to 0, then the surface is visible, and when we considering n1 dot p is less than 0, it is considered as the invisible. This n1 dot p1 is considered as the dot product. So when we considering this algorithm performing the steps like first step, do numbering of all polygons in clockwise direction, that is v1 v2 v3 vz up to vz. That means we just numbering the polygons. Step second, calculating the normal vector in n1, that is we calculating the normal vector each polygon like this one, n1 is equal to v2 minus v1 into v3 minus v2, right? Because v2 v1 v3 v2 is the adjacent vertices. Then next step 3, consider the projector p. It is projection from any vertex, and then we calculate the dot product, and the dot product are with respect to projector is equal to n dot p. So this here we considering this n1 dot p is the dot product. So step 4th, test and plot whether the surface is visible or not. And when we considering testing with respect to whether the surface is visible or not, we consider if dot product is greater than or equal to 0, then the surface is visible, else not visible. That means when we satisfy this condition, then the surface is visible, right? So this way we can study the backspace removal algorithm. Thank you.